problem 8C, our x value is equal to the cosine of t minus 1, and our y value is equal to the sine of t plus 1, where t is between 0 and 2 pi. So let's take a look at we'll make a little chart. And you wouldn't have to do this every time, right? I mean, you can just go ahead and solve for x or solve for y, but I think it's valuable to see the chart, to see what's going on, and just to try to get an estimate of what the graph looks like, whether you think it might be linear or nonlinear, or whatever it happens to be. So the first value that we're going to plug in, since t is between 0 and 2 pi, let's plug in 0 and see what happens. So if I plug in 0, I have the cosine at 0, so let's work this out right here. Now the cosine value of 0 is a left-right movement, which is 1 minus 1, so this guy is itself 0. The y value is the sine of 0 plus 1. Now the sine of 0 is 0, so y is going to be at 1. So I know that that point's on the graph, so let's just go ahead and plot that guy out. So 0 left, right, up 1, and I have a point there. Okay. Now I'm going to erase that so we have some room here. Now let's try, we could try whatever angles we want, but let's try, as long as they're between 0 and 2 pi, let's try, I don't know, pi over 2. So if we do pi over 2, now I had picked, when I gave you guys the angles, I picked just some random angles in there, so they weren't in a particular order, okay? You can just work your way around the unit circle if you want to. The cosine of pi over 2 is 0, and the sine at 90 degrees is 1, so we get 2 out. So here our x value is negative 1, and here our y value is 2. So let's go, so here's negative 1, here's 2. So that point's also on the graph. So let's keep going. Maybe we'll try another one like, well, I don't know, let's try pi. So this one here, by the way, guys, was at 0 radians. This guy right here was at pi over 2 radians. Okay, the next guy's going to be at pi radians. I'm following a pattern here, but you don't have to. So the cosine is negative 1 there, and the sine value is 0. So that means if I'm at negative 2 up 1, okay, so it's still good there. We're just plotting these points out. Let's keep grabbing some more here. Let's try, let's do 3 pi over 2. So that's basically at 270 degrees. So the cosine there is 0. The sine there is negative 1. So I'm going to be at negative 1, 0, which tells us that because negative 1 is going to be mapped to two different things, this is not actually a function, right? Okay, now it could maybe be a box, it could be a circle. So let's go ahead and check our calculator and see what that gives us. So I'm going to make sure I'm in radians, which I am, because my t values are going to be in radians. So we're going to go cosine of t minus 1 and sine t plus 1. Slide that over there. Now go to our window. Our t values are from 0 to 2 pi. How often do we want to step? How many radians per step? 0.1s are right. Okay. Our x value, it looks like we need to go at least -2, so I'll go -3. It looks like at least 0, so I'll go +1. Scale 1. Our y values, let's go from -1 to 3. And let's graph that guy out. Okay, so it looks like it's a circle, depending on, you could say, okay, this is more of an ellipse, but it really depends on what our screen is set at, right? And it looks here, obviously, like it's probably a circle. So let's just go ahead and sketch that guy in there. So let's take a look at this equation here. First of all, I've got sine over here and cosine over here. So if you were going to try to solve for this, okay, so I've got x equals cosine t minus 1 and y equals sine t plus 1. Well, what I would need to do is I would need to get x in terms of sine. So we need to go ahead and do something here with this guy. So I guess maybe what I could do is move this 1 over, so I go like x plus 1 is equal to the cosine of t, and I could do y minus 1 is equal to the sine t. Now you might say, well, why are you moving this over? So here's what I'm going to do. I'm going to square both sides. And now what I'm going to do is I'm going to add both equations together. Okay? So here's my trick. I'm going to add these two guys together. And now watch what happens. I'm going to get x plus 1 squared plus y minus 1 squared is equal to sine squared t plus cosine squared t. And we know sine squared plus cosine is 1. So now look what you've got. You've got the equation of a circle centered at -1, 1. So -1, 1, here's the center, where its radius is equal to the square root of 1, which equals 1. So it has a radius value of 1. Now, if you wouldn't have seen this, that's fine. Okay, I mean, I'm not expecting you to be able to generate that right away. Okay, maybe some of you did see it, and that's great. Okay, but if you didn't, what I do want you to be able to do is I do want you to be able to make a table and plot some points and be able to grab your calculator and see roughly what the parametric equation looks like. Okay, so if you have any questions on the parametric stuff, make sure you stop by and see me.